Hello everyone, I am Chezter. I'm here to discuss about electrical powers in physics. Watch it, I make some a video lesson, teach you, and learn some. Hope you like it.
Now we'll talk about electric power, and when we talk about electrical energy, we inevitably end up talking about electric power because energy and power are closely related. You might remember the formula for power. Power is energy over time. In other words, it's the rate at which energy gets used up. How many joules of energy get used in a given amount of time, in a given second typically. And joules per second is a watt, 1 watt. Or just capital W, 1 joule per second is 1 watt. Now electrically, power is still energy over time. We're just talking about electrical energy now, not kinetic energy or gravitational potential energy. But power electrically is still energy over time. But remember that electrically we have an equation for energy that says energy is charge times voltage. We can use that fact to do a little derivation. Watch this. And you can write this in your notes if you're taking notes on the page. Power is energy over time, and electrically energy is charge times voltage. So we get QV over T. I've just substituted that QV in for the energy. And Q, the charge, is the current times the time. So in place of the Q right here, I'm going to put in IT. So I have the current times the time times the voltage over T. So I've just taken the Q and replaced it with IT. And now when it's written this way, you can see that these T's are going to cancel out. And I'm just left with P is equal to IV. So that's one of our equations for power. P is IV. Write that down, put a box around it. The power is the current times the voltage. That means in any electrical device, any electrical device that has some current flowing through it and has a certain amount of voltage also is using energy at a certain rate. That's the power, and that rate is the rate of energy usage is always current times the voltage. Now we'll do some examples with this, but hold that for just a second. I want to do a little bit more with this equation first. Take this equation, P equals IV, and let's take Ohm's law. Ohm's law says that V equals IR. So let's take that and substitute it right there. And that gives us this. P is equal to I times IR, which gives us I squared R. So that's another equation for power. Now let's do it again. Let's take this equation, P is equal to IV, and take Ohm's law again, but now take Ohm's law written like this. I is equal to V over R. And take this and plug it in for the I right there. And that would give us P is equal to V over R times V, which is V squared over R. So we get two other equations for power that come from thinking about what power is and Ohm's law together. So in other words, we have three equations for power. P is IV, current times voltage. P is I squared R, the current squared, times the resistance, and P is V squared over R, the voltage squared divided by the resistance. And you might ask, well, if you want to find the power, which of these equations do you use? And the answer is simple. If you're given the current and the voltage and you want to find the power, use this equation. If you're given the resistance and the voltage, use this equation. If you're given the resistance and the current, use this equation. So, as is typically the case, You think about what you know, and think about what equations that you know are the case that can apply in that situation. Now here's a simple example. Calculate the resistance of a 40-watt automobile headlight designed for 12 volts. And 12 volts typically is the voltage for electrical systems in an automobile. Well, in this case, we're given the power. 40 watts right there is the power. And we're given the voltage V. And we're trying to find R, so we're going to use the equation in this form. P is equal to V squared over R. And in this case, we're trying to find R. So we'll just algebraically solve this for R, and we get R is V squared over P, and then we put in the numbers. V was 12 volts, so I have 12 volts squared, and power is 40 watts, so I have 12 squared, that's 144 divided by 40, that gives me 3.6, and that's going to be in ohms. 3.6 ohms is the answer. Here's another example. An electric heater draws 15 amps, so that 15 amps is the current, I. I is 15 amps, and it uses 120 volts, so that's the voltage V. How much power does it use? Well, if we're given I and V, we can calculate the power using the formula P equals IV. So we just do 15 amps times 120 volts. It's that simple. That comes out to 1800 watts, or we might write it as 1.8 kilowatts. Not too bad.
I hope you learned new and discovered something. That's all for now. Thanks for watching.